Lambert's law equation is the absorbance equal to the molar absorbity times the length times the concentration. Absorbance is found using the spectrophotometer. The molar absorbity or slope of the line is calculated by dividing change in y over change in x. If the spectrophotometer is not 0 prior to measuring absorbance, the slope of the line will be inaccurate. The length is 1 centimeter. Concentration can be found using stoichiometry after completing the dilutions of your stock solution. The first step in this lab is to fill each cuvette to the line with its proper solution. Quantitative data represents a number collected, most often represented as a quantity, while qualitative data represents a type, most often representing a quality. The purpose of scanning across all wavelengths is to find what light wave best measures the absorbance for the stock solution. The lambda max will give you the wavelength that should measure absorbance the most accurately. Lambda max is found to be the x value on the graph when the y value is at its max, and defined to be the optimal wavelength for the stock solution. The concentration can be found using stoichiometry after completing the dilutions of your stock solution. These were our solutions following the dilution. Next, we move to the spectrophotometer. Start by confirming that the spectrophotometer has been zeroed by placing the water in the spectrophotometer and clicking 0. Before putting any cuvette in the spectrophotometer, wipe the sides of the cuvette where the beam will enter and exit through. Place the cuvette in the correct orientation within the spectrophotometer. Properly close the spectrophotometer before scanning. Scan the absorbance of each sample and record the absorbance in your notebook. Now you can take the cuvette out of the spectrophotometer and continue with the rest of your samples. Once you are done using the spectrophotometer, use the absorbances you found to do your proper calculations. Finish the lab by cleaning up your workstation.